So on the top of the screen, we're seeing, does anybody know what that is on the top of the screen, this part? The raw signal, right. So the raw signal is where everything is just all together. So delta, theta, everything is all mixed together, beta and so on. Now you see that? I'm gonna see if I can pause it here. Okay, so I just paused it. And you see this here and this here. What do you think those are?
Blinks.
Right, so they're eye blinks. And you were probably best to tell because you know when you're blinking. But that would be considered an artifact because it's not necessarily just brain. It can be muscle that's doing that too. So every time the eyes blink, it's using the muscles to do that. And then there's something else that's called eye roll, where even if you have your eyes closed and you move your eyes, there's a signal that can be picked up. It's not necessarily muscle, but it's still able to be recorded. So this, the eye blink can be something that could interfere with the training if it's a lot. And also that's part of the reason why when you do a brain map, you're not recording, let's say if we need 2 minutes of clean data, we're not just recording 2 minutes or even 2 minutes and 10 seconds. We want 10 minutes.
That's right.
Because if you think about what it takes to get that cap on, to get the impedances all low enough, and to record, and the person's hair may be a mess if you're using a cap that uses gel and so on. If you didn't get enough data, you don't want to tell the person, oh, guess what, we have to do it again. You know, you want to get it right the first time so that they're done. You know, and then also when you're doing a brain map, you want to make sure that you don't make a mistake where you put too much gel. Because sometimes when you're trying to get the impedance low enough, some people will say, well, just more gel, more gel, more gel. If you do that, if you think about the sites being relatively close to each other, now you have this one and you have this one, and you squirt more gel, it's going to start spreading. And now it makes a contact between two sites.
Right.
So that's what we call a gel bridge. So it's electrically connected now, and then the readings are no good. So if that happens, you can't really fix it. You know, it's because in order to really fix it, you'd have to take it off and dry everything. But once you have that much gel, it's like the whole, you know, once you take the cap off, it would be like everything's sort of connected now. So they really have to do it on a different day to do another recording. So you want to be careful with that. And I'm sure on Monday we'll get into more of that detail. But we're recording now. On the bottom of the screen it shows how much time. So right now it's like 3.5 minutes worth of data. And you can stop it whenever you want. You can pause it. This is, again, the raw signal. And now to get from the raw signal to what the delta, theta, alpha, and so on are, we take it through the FFT. So that's why it says FFT here, fast wave transform. So you have a 2D, which is this graph, and that's showing 0 to 64 hertz. So each one of these bars is one frequency. And it's color coded, so this first section would be delta, that blue, and then this sort of purple is theta, and then this sort of aqua color is alpha. Then you have SMR, and then you have beta 1, 2, 3, 4, 5, and then you have gamma over here. And above that really would be sort of considered muscle activity. Part of the reason why we would have 60 over here is to see if we're picking up a lot of 60 hertz artifact or electrical artifact. So if I've got you sitting too close to the computer or something, we might pick up some artifact. Or if the lights that are above you are putting out a lot of noise, that could cause a problem. Even I see that her foot is relatively close to the power cable that I have here. It's possible, even though the cable is shielded, that you still pick up some electricity from it. I actually noticed one time I was walking past the store, and I had my, at that time I think it was a CD player, you know, and with my headphones and with the wire and everything, so it wasn't wireless. And I'm walking by and there was a neon sign, and when I walked by, I just heard, and it like totally interfered with what I was listening to, and I was like, wow, there's that much energy coming out of this sign, and I'm saying, I wonder what kind of effect that has on the people that are working in that store that are like right next to it and stuff. And you hear about, power lines near people's houses and concerns about that, and it's measurable.
Cell phones, I mean, they can measure, there's devices that measure cell phone radiation too.
Yeah, so the cell phones, and I'm glad you mentioned it. So really, I should have asked you to take your cell phone out of your pocket if you have it on you. Okay, so she was already sensitive to that, there might be some issues. So when you're working with your clients, you want to make sure either they turn it off, not on silent, because it still will put out energy. So they can either turn it off and keep it in their pocket, or they can leave it on but put it like on a desk or something, or a table that's not close to them. Because it will definitely put out energy, especially if it's sending or receiving a message or a call. You could actually see a spike in the reading when that happens.
What about ambient sounds? What is your opinion on sound machines? I've seen some practitioners use sound machines in their training area, but then I've heard, like Kevin said, absolutely not. And I was like, dude, you have so many, that's such a busy clinic, they have 6 treatment rooms down the hall, and I was trying to make the argument for a sound machine. And just to kind of do this, and he said, no, you want more brain, you want to get a real, whatever, I don't remember he just said no. And because
so he felt like it would be a distraction?
He felt that it would be a distraction, and but I was trying to understand why. I thought so many patients coming in and talking to the receptionist, and then all
so
that,
and
then they have a therapist in the back who was doing talk therapy, and I was like, isn't that a distraction?
I would think
so. What do you think, what's your opinion? Is a sound machine better than nothing, or what's your opinion on it?
I would be comfortable with the sound machine, especially if you think there's competing noises in the area. And also, I guess it partly depends what kind of training you're doing. So if you're doing more of like ADHD types of protocols, then I think it's probably not as much of an issue for me as far as that the place must be like totally quiet, that kind of thing. Because especially if you're dealing with attention, sometimes that's part of the problem, is that if there's something else going on, it's like your attention is like, oh, what's going on over there, rather than focusing on the thing that you're supposed to be focusing on. So in a way, it can almost
distraction's good.
It can almost be a test of like a real life situation, as opposed to this sort of false, environment. Whereas if you're doing alpha theta training or alpha training, and you really want someone to get into a deep relaxed state, it's more important to have the room quiet and even low lighting, so that it helps. But I mean, I would think that if there's enough noise in the room to be distracting, if you're trying to reduce the distraction, then a sound machine would probably help to do that. That's what I would think.
Okay.
My opinion.
Okay.
Don't get me in trouble.
Okay, I won't. That's just more from my understanding moving forward, that's all.
So, and so what we're seeing here is the amplitude being measured moment by moment of all the different frequencies. So at any moment you could see, okay, alpha is at a certain amplitude, or beta is at a certain amplitude, and it's constantly changing. So remember I said you can get 2,000 samples a second. We adjusted, and right now it's probably set more at like 256 samples a second, but you can see it's relatively fast. And then over here, so this is like moment by moment what's happening. Over here you have more of a time period of this. So this right now is set based on this. This is showing 5 seconds. So this is 5 seconds, and then another 5 seconds. So you can see a little bit more of a pattern over time. If we wanted to change this to show more time, we could change it. So here, I'm going to just make it 20 seconds. So now it's going to take a lot longer for this, and you can see a little bit even more of a pattern. But also what it's doing is it's making this 20 seconds, so it sort of compresses it, so it's a little bit harder to see the detail of like an alpha or beta wave when you do that. But it makes it a little bit easier to see a pattern there if you wanted to see a pattern. So usually we leave it at 5 seconds. The other thing that you can see here is the average amplitude for the different frequencies up to the point where we are now. So we've been recording for 11 minutes now, and it's showing what the averages are for each one of the frequency bands. So delta, theta, low alpha, high alpha, SMR, and then beta 1 is 15 to 18 hertz, beta 2 is 18 to 22 hertz, beta 3 is 22 to 26 hertz, beta 4 is 26 to 30 hertz, and beta 5 is 30 to 38 hertz. So what we usually are going to expect to see with the frequencies and the amplitude is, over time, you're going to kind of expect to see a pattern that's kind of like this, where this is amplitude and this is frequency. All right, so let's say we go up to, what did we do, say 32 hertz, let's say. And so this would be our high beta. And then this is our delta down here. So we're going to kind of expect to see a pattern that's kind of like this with the amplitude. So we'd have delta would actually be the highest, and we would have them sort of going down like this. And if we see something that's not kind of following that pattern, we would look at it and say, okay, is that something that might be related to the symptom? And so that might be part of what would go into protocol. This is if we're not going based on a brain map. If we're going based on a brain map, it's going to kind of show us that in a different form much more clearly. But if we're just looking at, say, doing a simple assessment where we just do like a baseline recording, eyes open and your eyes closed and so on, and even doing a task, we might say, okay, what's happening with these frequencies? And let's say, for example, we have somebody that has anxiety issues. Instead of it going down like this, we might see maybe this one is up here. And, maybe alpha, instead of being here, it's down here. So it's lower than what we would expect. So we're looking for anything that's like not sort of going along with that pattern that we could sort of make a case for in terms of setting a protocol. So like in this case, we can see, instead of it sort of being more gradual, you see like the delta in this case is showing at 21, theta is 13, so that's kind of a big jump to go from 21 to 13, and then from theta down to the low alpha here is from 13 to 5, and then you see the rest of it is a little bit more gradual. Now this one is a little bit higher here, but not much. This one is a little bit higher, but not much. So I'm not going to just all of a sudden make all sorts of explanations as to why that is. I don't have enough information. But it's something that, if I'm looking at this, it's something that I want to look at further, and based on the intake information and all, to see if there is anything that would make sense to put into what we would do in a protocol. So let's say if, in this case, I don't know, there might be a little bit of sleepiness going on, right? Because you traveled from Chicago. Out of state, right? And so, being a little sleepy, you would expect to have more of the slower waves. And then if there was, you know, a bigger difference here where, let's say instead of it being at 4 or so, maybe if it was at 6 or 7, then I might say, okay, maybe we want to look to see if there's any kind of anxiety things going on, you know, stress and so on. So maybe that would be something where we might decide to inhibit, and also here we might decide to inhibit. But in this case, if you're just tired, we don't really, we just need to let you get some sleep, you know. So you're not always jumping to, oh, we got to do this protocol because this is a little bit different, you know. But that's just trying to give you an idea of like the thinking that you would be going through as far as when you look at this and what you're kind of looking for. Another thing you're looking for is if there's spiking in an area. So like when we talked about brain injury, there tends to be a lot of spiking, especially in the slower frequencies. This red bar, we set that so that it will show the dominant frequency, which would mean where there's the most amplitude. And so that moves around, but you can see most of the time it's within those, the delta and theta area.
I actually raised my hand to be an example because I was feeling tired. Because I knew it would wake me up.
Yeah.
So.
All right, and now I want to try something else here. So remember I had mentioned before about muscle tension and brainwave activity both being electrical signals. So part of what we would do when we first hook someone up, we want to do the impedance test to make sure our electrical contact is good and our impedance is low. Then we also want to do something called a behavioral test. And that's really to see, is this really recording what she's doing, right? Because I could make a really dumb mistake like hooking cables up to her and plugging a different cable into the instrument. So, you know, it's recording, but it's recording the air, right? And those kinds of things happen. And that's one of the things you want to straighten out, like in the mentoring process, to see if I'm looking at data that you recorded and it doesn't make any sense, and then I'm going to look into it more and see if we can figure out what happened. So I want to see, is it really responding to what she's doing? So now just bite your teeth together and everybody watch this. You see that? And relax. So that's caused by the muscle. So when she bites her teeth together, the jaw muscles are putting out electrical activity, some of which is picked up by the sensors, even though it's on her head. And you can see when she was blinking, that also would do it. So if you just blink hard a few times. Okay, so you can see how it gets affected there. And relax.
A question about the behavior portion.
Sure.
Is there any thoughts you can provoke to make a person have certain spikes or get a certain, like, I guess, measurement?
You can. It may not be as dramatic.
Yeah.
So you might have to have a screen that's fairly sensitive, you know, set up fairly sensitive so you could see relatively small changes. So like you might do something like, for instance, I'm gonna ask you to do something that would increase the alpha, let's say. So don't do it yet, but I'm gonna ask you to close your eyes. And what I want everybody else that has their eyes open to do is look at two things. One, you're gonna look at the alphas to see if those numbers start to increase. Actually, it might take a little while for these because these are averages over time. So instead of looking at that, let's look at these bars to see whether they increase, and also look at this to see if you see more of those sort of bigger sine wave types of signals when she closes her eyes. So everybody watching? All right, so go ahead and close your eyes. Okay, open your eyes. I didn't see a lot. And again, it could be partly from being tired. And also you're sort of on the spot where everybody's watching you. And you're probably not relaxing that much. So let's try it one more time. Just close your eyes. Some of that's muscle from laughing. Now it's open. So we're kind of looking to see, are we getting more increases here? Not as much, not so much. You can open your eyes. Did you feel relaxed? Or
Yeah.
you did?
That time, yeah.
Okay. So you got a little bit that time. But that's one of the things that we'll look at. Another thing you might have someone do is you might ask them to do some math or something like that, and you would expect to see, a little bit more activity in the beta range, and that's like one of the reasons why I brought this guy here, so that, you could give somebody a mental thing to do. And use that more with the feedback screen. So like this is more of a recording screen that we wouldn't necessarily use for feedback, but then we would probably go to a screen something like this. So this is on an automatic threshold, which means that these bars are our threshold lines, and the computer is going to, after about 30 seconds, start to adjust those bars. And what it's doing is it is adjusting the bars so that the person will get about 80% of the time they're going to be meeting the goals. So it may need to raise it or lower it so that the feedback stays at about 80%. Now, I only suggest that people use the automatic threshold until they're more comfortable setting manual thresholds, because I feel like the automatic threshold can kind of let people off the hook too easy, and it's not sort of pushing the person as much, in my opinion. There may be some sorts of automatic thresholds that do a better job of it, but it's been my experience that it's better to set the threshold yourself, and then you can kind of see if the person can kind of bring it back, where they're getting feedback and then they stop getting feedback for a while, and is the brain figuring out what it needs to do to get back to getting feedback again, rather than me just making it easier so that they're getting enough feedback. So what's happening here is you have 3 different conditions that have to be met in order to get the feedback. And the feedback is that sound. So you hear the sound coming on sometimes. And it's also this picture moving. So instead of the picture moving, it could be other things. It could be a Pac-Man game. It could be a movie that's playing or not playing, or shrinking or expanding, or getting more clear or less clear. But that's the feedback. You can also have points. So on this screen I don't have points, but you can have points. And over here is where you're setting what we're doing. So this one is tied to this bar. Right now it's set for delta, 1 to 4 hertz. This one is tied to this bar, and it's 12 to 15 hertz, or SMR. And then this one is tied to this bar. It's set at 43 to 59 hertz, which is not really an EEG frequency, it's more of muscle tension. So if, like say, you bite your teeth together, you see how this kind of goes up and relax? This one also went up. So that's more to keep the person's muscles more relaxed. But this could just as well be high beta. So if there was anxiety and we wanted to decrease that, we might set this, say, 22 to 32 hertz to inhibit the high beta. So all 3 of these things have to be met in order to get the sound to come on. We could just set a screen up where it just has 1 bar, and so only one thing has to be met to get the sound. The other thing we might have is we might be doing coherence, where instead of it being based on amplitude, we might have 2 sensors, and we're training whether there's more coherence or less coherence. That's not necessarily an amplitude, but it's more looking at the relationship between the 2 sites. And in that case, we would be getting feedback based on that. Okay? And of course, we have the raw signal here. Part of the reason to have the raw signal on the screen is to make sure that we're getting a clean signal. Sometimes what can happen is you start out the session fine, and you have one of those people that play with the cable or something, or they turn around and the air clip comes off. And you're still looking at this, especially if you're using automatic thresholds. The thresholds, however bad the signal is, the threshold will try to adjust so that you get feedback. So if you're just looking at the game or the picture or whatever, it may actually look okay, but the signal may be terrible. And so that having that raw signal on the screen makes sure that you always know whether you have a good signal or not. If you see something happen with this, let's say it starts to look like those vertical lines. So just bite your teeth together again. So if it's doing that, you might look at the person and say, okay, relax your jaw. Or if you see them doing this, squinting, looking at the screen, you might ask them, can you see the screen okay? You know, and then if you can move them closer to the screen or move the screen closer to them or whatever, so they don't have to squint, or if they are supposed to be wearing glasses and they're not, ask them to put their glasses on. You know, when you're hooking the person up, it might be easier for them to take their glasses off until you have them hooked up. But once they're hooked up, they can wear their glasses. Or if they wear contacts or whatever, they need to be able to see the screen without having to be tense. Or you might see them doing, you know, this, looking at the screen or raising their shoulders, get them to relax their shoulders too, because especially if you have a sensor near the back of the head, if they're tensing, you know, those muscles are connected, so you can pick that up too and get artifact. Okay. Any questions on this screen? No? And raw signal, you kind of see how we're going from the raw signal to the actual filters. And we go back to this screen. Remember, we're taking the raw signal, putting it through the FFT, and then we get the amplitudes for all of the different frequencies there. And then these are our amplitudes for delta, theta, all the way up to beta. And then what we're going to do is get her unhooked so she can be more comfortable like we are. And now I have two different kinds of prep pads. Well, not prep pads, I should say. There's the prep pads, which have the abrasive in them, and then I have some plain alcohol wipes. So the plain alcohol wipes are more for cleaning, like once you finish to kind of wipe the skin off, and also you can use them to clean the sensors off. You're not really supposed to use abrasive pads to clean the sensors off.
I was actually to like someone made it a strict point about using alcohol continuously in the sensors. It'll take away the silver or whatever material is used to make it.
Right.
And eventually it'll wear away or
correct.
Become damaged.
Right, and some people will only feel comfortable if they use alcohol to clean things, which I can understand that.
Yeah.
But there are other ways to clean them. Soapy water is less abrasive or damaging to the sensors. Even using like something like a Lysol or something like that would be less damaging than the alcohol, or especially the abrasive alcohol pads, because they're actually scrubbing the surface.
I see the cap was like submerged, so I think that's a different type of cleaning.
With the caps, what you do is you submerge those in soapy water.
Yeah, that's what you.
And then you run it under warm water to get any of the residue out. And like even with these, let me just get this off. Just lean forward. Thank you. Okay, you are free. So, and don't forget your earrings and your Fitbit. You know, you can actually end up with extra earrings, if people forget, so I want to remind them. So with these, you can just wipe off the excess. I like to use Q-tips to kind of push the paste out of the cups. And then once you get most of it off, you just run them. You can run them under warm water or clean them with soapy water. If you feel like you have to use something else, you can use the alcohol, but you have to understand it's going to wear your sensors out faster.
But we're not, you're not hindered by like any OSHA standards.
Well, there are some standards that the AAPB actually put out some standards for cleaning electrodes, and I'm going to send that to you in a PDF.
Thank you.
So you have that. But you can also get like, I was actually, there was something I was at recently, and so they were talking about using a cleaner, like a Lysol type of cleaner, and that has stuff in it that is supposed to be able to kill anything that would be a problem. And they even have the wipes, you know, if you don't use this spray, you know, they have the wipes that you can just use instead, so. Yeah, so you can get them like the, you know, like you get the baby wipes. You just have them in that kind of container and do it that way. So, I'm gonna go through the 1020 system, and then, yes, thank you for reminding me. Let's take a break, and then I'll go through the 1020 system, and then after that, we're gonna do a lab where everybody's gonna practice and actually do these hookups.
All right.
Glad somebody said something about taking a break.